Ah, kids. Hey, we're gonna do a little lab using LEDs to try to figure out Planck's constant. So let me show you the stuff that we're using here. So, can you see my circuit there? You are gonna want to pause this and write down the different wavelengths of the different lights. So let me just show you. Like if I adjust this, you can see I get different light. Hey, that's pretty sweet. Over here I don't get light because that's not in the visible spectrum. I'm getting light, it's just infrared, so it's not in the visible spectrum. But there we go. So we'll start at the 471. I can adjust this. This is a resistor that I can adjust to allow more or less current across here, or more or less voltage across there. This is going to be where my voltmeter is, and that's going to be more where my amp meter is. So let me angle this so you can see it. So right now, currently, okay, this is measuring current, and it's in milliamps, so it's 3.9 milliamps, and this is in volts, so it's measuring 2.85 volts. So here's what we're going to do. So you can see my little blue LED, so that I am starting with electrical energy, okay, and I'm getting some light energy, some HF, okay, but, okay, I'm also have a little bit of extra electrical energy. So we're going to change the resistance until the first time this goes away, and then we're going to record this because we're going to assume, and it's probably not a perfect assumption, but we're going to assume then if I don't have any extra electrical energy, we're going to assume all of the electrical energy at the start gets converted to HF. Okay, so again, this is the 470 wavelength, 470 nanometers. So let's slowly adjust this until it gets to 0. So you watch the current going down. And looks like the first time it's 0 is right about there, maybe. Yeah, so probably like 2.3 volts. Okay, so we're going to go with 2.3 volts for the 471. I'm going to go to the 550, and you'll notice when I go to the 550, it goes up, so 550 nanometers. So again, let's slowly lower it until it gets to 0, and 0 right about there. So 2.27, 2.26 volts. All right, so let's go to the 570 nanometer wavelength one. So again, I want to slowly lower this. Oh, I should probably do it this way so you can actually see the light. So slowly lower this. Look at the, and when it gets to 0, we will record our voltage. And right about there. Okay, so it looks like the 571, it looks like you're like 1.71 volts. Okay, so now we'll do the 605 one. And let's see again. So we'll slowly lower, 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 lower it until, okay, right about there. It looks like 1.53 volts. Then we'll go to the 655 nanometer one. And let me slowly lower, lower, lower until that one goes out, or barely lights, I mean. Right about there, 1.46. Now I'm going to shift it to the 880 nanometers. And now this one, it doesn't give off any light because it's not in the visible spectrum. Now, well, actually, it does give off light. It's just not giving off visible light. Okay, if I was a snake, I would actually be able to see that because snakes can see infrared. And you might think I'm a snake, but All right, let me lower that down. And it looks like for that one, it looks like 0.9. What are these? 0.97, 0.97. And then we'll go to the last one, 940 nanometers. And again, it doesn't give off any visible light. But if I lower this to make it, excuse me, 0, 0.8, I'm going to go with 0.81, 0.81. Okay, all right, so that should be good for your data. Remember, we are assuming that all of the energy is getting converted from electrical to light, and if it's not, well, then you'll have to deal with that. So yeah, all right. Bye, kids.